about the resistance. In one nutshell line I wanted to tell you, the value of a resistance of any conductor is directly proportional to the length of the conductor. Suppose say, if I buy a cable, connecting cable, set up, and if I measure the resistance of the cable per meter, 1 meter, and if it is 1 ohm, then after 100 meters of the cable, how many ohms is offered by the cable? So simple. That means the resistance of the cable is directly proportional to the length of the cable you have. Okay, my dear friends, that is one thing. Second thing is that resistance of the cable will decrease with area of the conductor area, cross-sectional area. Okay, that means resistance of the conductor is inversely proportional to the cross-sectional area. Yes or no? Now, this is what explained in books, Naimisha. IIT questions and all. Now, the problem is what children doesn't know about this cross-sectional area. So, how this resistance is inversely proportional to the cross-sectional area of the conductor is also an important question. If anyone can explain me what is this, like the resistance is inversely proportional to the cross-sectional area, I will be very happy about it. Who is that going to explain me this? Shall I tell you that, or anyone is going to explain? Resistance is inversely proportional to the cross-sectional area. So what is that cross-sectional area and how it is inversely proportional to that particular cross-sectional area is more important for me.
Because the frequency of the
so that is very important. Okay, now let me make you understand. So this is a conductor wire, and suppose say every conductor has got its own diameter or not? Suppose this is a wire. Does it have this diameter or not? How do you measure the diameter of this?
When a class.
Sure. R square into pi is going to be cross-sectional area. So, if this cross-sectional area of the conductor is more and more, the resistance in the conductor comes down. More the cross-sectional area, lesser the resistance. Lesser the cross-sectional area, more the resistance in the cable. That means, whenever you wanted to make sure that more current is supposed to be go, then you need to have more cross-sectional area cables. For the more current, more cross-sectional area cables. For lesser currents, thin wires. Okay, you understand, my dear friends? So, that is the secret. Oh, that's it. Give me fast, we need to finish. Okay, listen friends. ఇప్పుడు ఒక మంచి మాట చెప్తాను చూడండి, కేర్ఫుల్. You all have ACs at home? Air conditioner. For ordinary regular light fan and all, you don't have to use that thicker cables. But for ACs, you need thicker cables. If you connect AC machine on regular 100 watt, that bulb, that wire and all, the moment you switch on your AC, next minute you will only see sparks and smokes, whatnot, the smells and whatnot. Why? Because AC is trying to fill more current, around 10 to 12 amperes. And these wires are not meant for more carrying current more than 1 ampere. So when AC is trying to put that current and these silk wires are not sufficient to carry that much current, then the resistance inside the cable will become heating element, because high is high, I square R is much high, and automatically the plastic will get melted because of high heat, and then they short circuit, and what might happen, just imagine, please go and the wire will get damaged and bad things. You understand? So to carry high currents, we need to have thicker cables, because resistance is directly proportional to the length of the conductor. Resistance is very much less if the diameter goes up. So thicker the cables, lesser the resistance. So whenever you wanted to have more currents in a circuit, you need to have thicker cables. Thicker connectings, as we said, connectings, okay? This is what is important, the basic point. From this basic point, you can become master of electrical. From this basic point, you can become master of electronics. So one has to have thorough, clear understanding of this R proportionality thing, L and A, very important area. This is going to rule. Okay, I will give you a very good homework after the practical class about this ohms now, about the R and proportionality action. Okay, I will give one.